All right, class. Today we're going to do some further practice on our CPCTC proofs. And we're going to extend it a little further, and we're really going to be into, and I'm just trying to put some paper up under here, some overlapping triangles. So the video today isn't going to be very long. I'm probably only going to do one proof. And we'll practice this some more in class on Monday. It's the weekend, so I hope y'all are enjoying it, and so we won't be too intense. The big thing when we're dealing with these triangles is really to be able to kind of pull apart the triangles to be able to see what you've got. So when you have a lot of triangles like this, it's not a bad idea to draw some pictures or pull apart the triangles into a couple of triangles, especially when your given statement is something like this, where it's really talking about congruency of two sides of this big triangle. Okay? So really, to look at it, you're going to have to separate it. And then, interestingly enough, this given statement deals with two sides of this smaller triangle, which are going to be pretty important to our proof. Now, what we're trying to prove is CHR is congruent to RIC. So these are the two angles that we're focused on proving they are congruent. And what I begin to see is that these two triangles are part of this triangle I should say, and this triangle. So to make it simpler, it's probably worth pulling those triangles apart too. And this is where you've got to pay particular attention to your labeling. One, making sure you're labeling the triangles correctly, and then using that to help you understand some things about congruency. So first, let's look at this first triangle. It tells us that CA is congruent to RA, which I've marked on here. That means this is an isosceles triangle. So this angle and this angle must be congruent. All right. Then it goes on to say that CS is equal to CR. So now I'm focused on this smaller triangle that I'm just shading in right here. Okay. First I was focused on the big triangle, just to be clear. Now I'm focused on that smaller triangle. And in that triangle, it says these two sides are equal, and it names two angles, 1 and 2. Well, once again, this is an isosceles triangle, so this angle 1 is going to be congruent to this angle 2. All right, so now let's look at our bigger triangle. This triangle CHR actually has the angle 2 in it. And this triangle CIR actually has the angle 1 in it. So I already know from here that those two angles are congruent. And now from here, I also know that C, or ACR, okay, ACR is this big angle here, and is this angle on this triangle. no, if we keep going, A's up here. So don't get confused by that. I could say HCR, this angle, because there is another point on this line. And it's congruent to this angle over here, IRC. So I marked those two angles congruent. Now, when I look at this line, CR, it's the same segment here, CR. So definitely CR has to be congruent to CR. So I see where I could make these two triangles congruent by angle, side, angle. Okay? So now that I've kind of worked out a little plan here, I'm going to write my proof. And I know this says to do it in a flow proof, but I think it'll be easier for y'all to understand if I just do it in a straight 2-column proof. So, I've got my statement and my reason. Okay, so my first statement is, CA is congruent to RA, Y it's given. CS is congruent to RS, Y it's given. And so now I'm going to deal with the fact that this is an isosceles triangle. So I'm going to say, and this time I'm going to use H, but HCR, that angle, is congruent to IRC. Why? Because of isosceles triangle theorem. Right? It says if two sides are congruent, then their base angles are congruent in an isosceles triangle. Next, after I've proven that these two angles are congruent, I'm going to go to the smaller triangle and I'm going to say angle SCR is congruent to angle SRC. And once again, isosceles triangle theorem. Okay? So now basically I've got this angle congruent and this pair of angles congruent. So now I have to deal with this side CR. So I'm going to say CR is congruent to CR. Why? Because of the reflexive property. And so now I can ready to name my triangles congruent. So I can say triangle CHR is congruent to triangle RIC, and it's by angle, side, angle. And now I can move on to say that angle CHR is congruent to angle RIC. And what is the reason? CPCTC. Okay, so this was a good example of how when you've got complicated triangles like this, you've got to kind of pull them out, see what you know, and then separate them so you can really hone in on how to find the angles or sides that you're trying to prove are congruent. Okay? All right, so this is it. Just one video tonight. Make sure you're keeping up with the assignments, though. There were a number of assignments that you were working on overnight today. Have a great rest of your weekend, and I'll see you on Monday.